Hi, folks. Welcome to the December 9th European and USA Embedded Special Interest Group meeting as part of the Bytecode Alliance. So welcome everybody to that. Checking the agenda. We don't have any agenda items on our meetings backlog yet, but we do have a number of people on the call. So what we traditionally do is just open it up to general conversation, see if folks have things that they would like to discuss or questions or prods for progress and status updates, and we can answer those, and then we'll wrap up the call. It is getting rather close to the holidays, so I think we probably have a couple of clashing meetings over that period. So just so you know, I will start sending out emails to folks who are on the email list and pinging Zoom, Zulip with updates to let people know that these calls are cancelled, and the calls are also scheduled in the Bytecode Alliance calendar, which is awesome. David's done a lot of hard work making sure the calendar's up to date with all of our meetings. So I will also ping him and ask him if he can remove the clashing holiday meetings from that. So there'll be some schedule updates. Please keep an eye out for that. And I think that's all the housekeeping items I have for now. Folks, how are things going? Any status updates? Any questions? Any concerns? Anything you would like to talk about? Could be a very quick meeting.
I would like to request from Stephen and yourself, and really anyone, just because I've been out of touch with these meetings for a bit,
Mhm.
but and it just so happens we're at the end of the year. What do we collectively think? Let's just make it a trivial three. What were the three things that we accomplished this year, and what are the three things we'd like to see getting started next year in the form of a status?
Ron, I love that question. It's nice to do a little retrospective. Um, I think what we've done this year, when we got the eSIG started the year before, and this year was really about trying to work out how we work together, what was important. It took a very long time to get a document together that outlined the platforms that we wanted to focus on. It then took a really long time to work out. We had some pain points about and great discussions with Luke. So thank you, Luke, um, about the component model and how we would work with that, and the the contrast between some of the very small devices that have a lot of constraints and the um, the need for some extra CPU cycles and some of the uh, determinism around memory allocation and stuff that was going on inside the component model that made us um, pause on that one. So it's not that we thought the component model was not the right way to go, just that it just didn't fit at the time. So it took a long while to get to that point, I think, and it was just a lot of people heading in the right direction with a lot of goodwill, but stepping on each other's toes. So I think for this year, getting through all of that and getting to a position where we agreed, hey, you know what, we really need this long-term support thing. That would be kind of important. And then the next bit is trying to make that happen. So it seems to take a long time to get to a point of consensus, and then a little bit longer to try and make that actionable. But I think we're getting there. For next year, I would love to see some more progress on the LTS work and seeing some of that stability. I think um, I gave some presentations on it at some academic conferences and at the W3C event with Stephen, where we basically talked about how it's just making sure that the feature set, it's not, and this is an interesting thing because it isn't really bytecode alliance-y. It's more just an artifact of how WebAssembly is developing. There's some amazing new features coming in from core WebAssembly, which are really great. It's just that the features aren't always supported by the runtimes that are deployed in embedded systems. Then the compilers get updated, and then WASI gets recompiled using the latest compilers, which turn on the features that the runtimes that we have in the field don't support. And so we get this need for long-term support where everything's kind of kept in sync and we have feature parity, but we still have all the security fixes and CVEs patches and everything we need for that. So there's a bit of work in getting that together. And at first, that seemed like a giant mountain of work to get done, but realistically, it's just like a downstream version of some of the projects, like a probably very lightweight fork, and then contributions to that would be essentially CVE patch pull downs, and if necessary, on the usual case where we have new features that we'd have to deliver, we would add them, but try to propagate it up. And it took a lot of time to work out how that would work, and I had some fantastic conversations with Rob, who's also been absolutely amazing in this one. So he gave some great advice and guidance on that. So big thank you to everybody there. So that's my take on last year and probably next year. Stephen?
I would agree on the take from last year. I think, all these things take longer than expected to form and storm and kind of get to some normative organization. So I think we're kind of through all that now. So I agree with what you said there, Chris. I think for next year, I think or what I'd like to accomplish next, I think I'm pretty aligned with that as well. Like I think there's some processes and stuff we need to put in place around how do we provide stability? Like what do we mean by stability in terms of long-term support? And how does that, like, from a tactics perspective, work out, right? So for example, and this was actually one of the things I was going to talk about or bring up in this meeting is the WASI SDK comes out and it's usually like a major version, or not a major, it's just a single version. So I think we're up to WASI SDK 28. And what you typically see with that is they update to the latest version of LLVM, they update to a bunch of things, right? And moving to a new major version of Clang is probably not something some people want to do right away. They might want the bug fixes that might have been done in the SDK in Muzzle, but not necessarily jump to the latest version of the compiler. Now, I understand why the WASI folks do this is because it's a moving standard. They need the new features that are coming in WebAssembly. They need the compiler support. They need the optimizer, the linker, and all that other fun stuff. So they want to run on the bleeding edge. But folks who require stability may want to not jump from, say, LLVM 19 to 20. They may want to stay on the latest patched version of 19 until they qualify version 20 of LLVM. So what we might need to do, and I'm not saying this is what we should do, but what we might need to do is have interim releases where, like, hey, this is SDK 25 with the latest fixes or the latest versions of the point release of that same compiler. And then obviously it compiled for that. So you get that kind of stability. So what does that mean? So I think we need to define what that is. Fortunately, I think, as I understand the WASI SDK, this is actually, you say a lightweight fork, and I agree with that. I think there's an easy way for us to do this, because if you look at the WASI SDK, it itself is really a shell project, right? I mean that in a good way. It brings in LLVM, it brings in Clang through a submodule, and it brings in the WASI libc. And so we can probably make a lightweight fork, or actually potentially, we would need to make a fork because it's a W3C project, so we don't own that as part of the bytecode alliance. So we'd have to make a lightweight fork, but we could probably have a different makefile, for example, that builds these things using, the older version, the new version of Clang 19, and not the latest version 20, right? So there's a couple things that I think we could do that are actually pretty lightweight and are just minor things that we'd have to do inside of a makefile. It would not entail like a complete fork of all the source, for example, right? So anyway, I think understanding what those mechanics are for what we mean by stability, because I think what folks like the industrial software side of the house want and demand are different than what the current WASI development is, and both are important, but different needs. So we need to sort that out. I think, if I understand as well correctly, this may not be as much of an issue going forward, but now with the release of Line 1, which stands for like linear memory, I guess options 1, that may get rid of some of the optional chaos, the chaos around optional features in WebAssembly, right? Line 1 is a culmination of a number of different WebAssembly, post 1.0 WebAssembly options that had been optional, but de facto being used. And so I think WASI libc now is based on Line 1, at least for the P1 target, and from what I understand, will stay on line one. So that should provide some stability. But of course, at some point, there's going to be another option or a line two or a line one plus something else, right? And we'll have to deal with that. So what is our plan for that, and how would we support that going forward? The last thing that I would say is Chris and I at the last W3C meetup, we're talking about the C API for runtimes. So as you know, there's a standard API for embedding a runtime in a host. That is largely sufficient for running WebAssembly inside of, your application. So if you're using WebAssembly and you want to run a WebAssembly executable inside your host, you can go do that, right? And we do that as part of our Project Ochre and Atom as well. But what you can't do with that API is add imports into that, right? So if I want to expose a function from my platform or from my application that the WebAssembly environment can import and call, that is proprietary to the runtime. And so one of the things that Chris proposed, and I actually did some work around this at the W3C meetup, is, hey, if we standardize that, that would be really cool, right? And it doesn't look like that's actually all that difficult to do, because all of the runtimes effectively do very similar things, just with different syntax. And so if we were to standardize that, I think that would be a really useful thing, which leads into the thing I'd like to see in 2026 is support for the component model through something like what is done with Jco, right? So Jco takes a component, unwraps it, and then that makes it runnable with some platform extensions on a P1 or a core WebAssembly runtime. And so I think that is actually really interesting for us, because it would allow us to, when we need to, run components, but still keep the runtime for things like WAMR lightweight and supportable on embedded. So if you need it, you can do it. And if you have the resources, you can light that up. But not everybody would have to have that built into their runtime and could save that code space. And so for embedded targets, industrial targets, that's probably really good to have that option, because then you can really optimize for what you need and enable just the features you need. So for example, like in our platforms, we don't enable JIT because we don't like the unpredictability. Sometimes things run fast, sometimes they're compiled, and the overhead. So we just turn that off, right? And so having that ability is important. So I think being able to turn on component model support and then do it through what is done with Jco, and then potentially, taking what Jco does in generalizing it. That's the word I'm looking for. So that it can be supported on any runtime. There's a project for WA0 called Gravity that is basically Jco for WA0, right? And so if we had a standard way to do this extension mechanism, we could have a standard way that works across all of these, and then you wouldn't need Jco and Gravity. You just have one solution for the component model running on these core runtimes.
Right.
So anyway, that's a lot, but that's my wish list.
Yeah, I think the research problem we started with was, could you create a universal plugin for any WebAssembly runtime that could add some extensions? So it's just one binary that works everywhere. And we kind of proved out that you could do that, but it would be nicer if you had a standardized interface. Then the idea is that for instance, for WAS0 or WASM time or WAMR or WASM Edge, you could supply a single binary as an extension. And then Stephen got super excited. It's like, awesome, if we had the platform extensions that seems to be in Jco, and I haven't looked at it in the depth that he has. It's like, oh, then we could have the component model for free, because we just had this plugin and it would provide the bits we need, and then we could take a Jco-like approach. I'm like, that sounds pretty cool. That sounds really cool. Sounds like we get it for a lot of runtimes without having to have the runtimes make lots of code modifications as well. So that would be cool. But yeah.
Do we have a document of some of the examples of some of the specific host runtime entry points that we thought were universal?
No. Chris did some work and prototyping around that to prove the art of the possible. But I think the idea of presenting this at the W3C meetup was to be like, hey, is this really stupid? And would people really think that this is dumb, or do people think it's useful? And I think people were nodding. So I think the next step would be to probably draft that out. I don't know,
Yeah.
Chris. What do you
There
think?
was some polite nods, but no standing ovation. I put it that way. It's like
Yes.
it was like, yeah, okay. So we were just kind of raising it. I think from a um, plugin point of view, there's a lot that's already in the. So this would be something similar to the WASM C API, but we'd want to have it for some additional extensions. Um, so that you could inspect a component, inspect a module, sorry. From the plugin point of view, you need some of those APIs for memory address translation and bits and pieces like that, but you'd also want to have bits for um, its um, module inspection. Like one of the things that we were looking at was just to make this really hard, right? If we're going to do this, and if I was going to do this, then could I do it for a completely different platform? So we have WASI, but could I do it for a completely different platform, which doesn't even have the same reactor style initialization sequence as um, uh, a WASI module? So we have none of the C structures initialization stuff. We have a completely different naming convention. The start um, for running the main function is slightly different. How could I build a plugin that would allow that to happen? And so you go, oh, well, I can get so far. I mean, I can provide additional functions. That's okay. But now I've got to think about my initialization sequence. So the runtime would need to allow me to register for that or provide me with a mechanism to say, oh, hey, I've just got a new module and here's its function signatures. Initialize it, please, and just delegate that responsibility. So that's the point we said, well, there's probably a suggestion for a change to allow that WASM C API to be extended to provide that type of functionality. And that's about as far as we got. We got a proof of concept working, and we said, hey, we can make it work on WASM Edge and WAMR. Um, you know, reading the documentations by zero looks like it would be fairly straightforward to do. Let's stop and present and just see what people think at this point before we move forward. So that's as far as we got, but we could do a lot more in describing what we did, in fairness. So could be an interesting presentation for another ESIG in the future. Happy to go through the details.
Yes, please, and thank you.
Cool. Good questions. I like it. Stephen, did you bring up everything you wanted to bring up? Because you said this was highlights, but we glossed over
Yeah.
something.
Yeah. No, I think that's enough. Um, I don't know if anybody else has thoughts. I think the other thing that I know was in flight that's only I would say that we're interested in, but I think general WebAssembly and general WASI is looking about as that shared memory um, zero copy. We've called it various different things, but basically WAMR has a technique for sharing memory across multiple WebAssembly modules. And I know the web GPU folks on the core WebAssembly side had that same need. And there was some interest in taking the approach or a similar approach to what WAMR did, not necessarily the same implementation, but something similar to support that. I don't know if I've not heard of that moving forward in the core WebAssembly folks. So that might be something that we want to coordinate if that's to be standardized.
Mhm. Yeah. The other thing that's been on my radar, Ben brought up at the in-person meeting, which if you were there, he even had an AI generated soundtrack that with a song that described his feature proposal, which I thought was epic. Um, if not, hopefully it's on video and you get to watch it. But he had this concept of WebAssembly being able to generate a function in a WebAssembly function, and then essentially at some point be able to execute that function. So you have dynamic code generation, and really he's looking at that as an extension to support interpreted languages, so that you could bring over a lot of the interpreters and how they work for it, which would be pretty cool. one of the scenarios we have in the industrial side is the ability to hot swap code. We'd like to change the code in a running device and without bringing it down. So at a known point in a control loop, swap out some functionality. And then the question is, well, how do you do that in a really efficient way? Maybe this would be a way. Maybe thinking about what we could do with WAMR to extend it to have dynamic module loading and unloading, and how could you do that really efficiently? There are limitations, of course. If you completely change the function signatures in the module, it's not really going to work, but that should be okay, right? So there are things that we started to think about. I think will be coming up this year, at least in our radar, along with the LTS stuff. I don't know. We should open this up to everybody else as well.
Yeah, I was real quick on this with the dynamic compilation. The thing that really struck me in Ben's presentation was one of the examples he gave was using this for Python, which, as we know, Python is often used in the ML stack. And so you could use that approach to compile down Python to WebAssembly so it's not being interpreted and get better speed. So people who want to use Python, for example, for lightweight coding or extensions in like an IoT scenario, we can then compile that to native and not have to run it as interpreted. So I think there's a few of those things that feature opens up. Python being one of them. Hot swap is another. So.
Wow, that's so much less exciting than I thought you were about to say. And between Lisp parentheses and WebAssembly, suddenly they got together and that was it. Became self-aware.
Well,
anyway.
you could use it to compile Lisp if you wanted to.
I was trying to resist the temptation to go off and do a search to see if somebody's already done exactly this. I bet they have.
Yeah. Okay, so that's what Stephen and I were thinking. We should open it up. So the question was, what do you think we did well this year, and what would be on the wish list for next year? Go on, Ron. You threw the question out. I'm going to throw it back at you.
I think he wants Lisp support.
Well, I mean, it's been a very interesting. The speed in which industrial computing systems versus the speed at which web developed systems operate, resolving that dichotomy, I think has been very interesting to watch. Preview 1 has sort of become the de facto standard, whether we liked it or not, for a lot of plugins and, things that maybe would be considered embedded. So was that a success or a failure? It was a success because at least there was some standardization. Maybe it was not a success as far as getting more advanced features adopted more broadly. But that was very interesting to see. Again, Rust continuing its, sort of pole position. Go not doing that much outside of TinyGo, where adoption is very focused on P1 stuff, just because there's a lot of people using it for neither web nor embedded scenarios, for Privy, security scan, and other things. So, but I thought we did a great thing to at least establish that there was an embedded interest in WebAssembly broadly, with important companies that are staking a claim of saying, yes, we're doing this, so we want to make sure it's there. 2026, well, we have a lot further to go, obviously, to, we have an LTS concept, but I'm still not sure how that shakes out. Maybe there's service offerings that Stephen's about to launch that will support that, or somebody else, other companies. Maybe it'll just be a well-funded build server. that builds these frozen or pinned versions and makes sure that there's always like a trusted binary download source of truth. You know, you can choose to mirror that, but at least we know it works at all points. You know, that might be enough. You know, versus a bunch of documents that maybe like a completely successful build that passes some type of tests that we've established are necessary smoke tests for certifying that this is fulfilling the requirements that the LTS is asking for. I'd like to see a lot more work done on the definition of exposing host functionality to modules, which I mean hardware specific things that are much more tied to embedded versus general host capabilities. I was hoping that that was kind of what you were talking about, but then I gathered actually you were talking about much more mundane and crucial things like how do you save a file or open one or whatever, you know, versus more of the embedded type control systems stuff. That was what I thought, or I think of immediately. You know, that's kind of the most important part of embedded systems, probably. And I know that we've had a couple of people talk about that, maybe on a very low level. I'm not sure we can define that as a standard, but the thing that Stephen was mentioning and you were mentioning, Chris, about some type of discoverability, maybe that just takes the form of, okay, cool, we're going to use WIT files that describe these things that you publish for your application, and then, you know, publish wrappers for module developers. You know, that's something that's been very much associated with the component model, but that you do not actually need to use the component model to use. You can use it with WASM unknown. So maybe if we get more people to know about that, that might serve as a, I mean, gravity is a lot more on the host side, not, at least from my reading of it, not on the client side, but you still need to have both of these things, you know, to create a coherent set of interfaces that you'll either your internal development teams use to work on different variations of your product line, or your customers use to extend your commercial device, you know, whether it's OEM or, you know, highly configurable on site. Some way that we can say, here's how you should go about doing that. Maybe it's patterns and practices more than actual code. But I'd like to see some of that in 2026 because I think that would help a lot to establish, here's how you should go about actually developing applications that use this stuff. Anyway, that's my €5. Started out 50 cents and it just kept appreciating. So I yield the floor back.
I think real quick to your build server idea. I talked to Dan on Luke's team at Fastly, who's one of the key contributors to WASI libc and WASI SDK. There is a bytecode alliance. So that is a W3C WebAssembly repository, both WASI libc and WASI SDK. But the bytecode alliance actually has a fork of it. It's just stale. It's not been updated. But what we could do is we could, and his suggestion was you could fork it there, and then we could have our own branch for these configurations, like I mentioned. And then all the CI/CD build stuff just happens via GitHub Actions already. So we wouldn't even need a build. Well, in effect, our build server would be GitHub, right? And so some of that stuff already exists. So a little bit of mechanics to make that work, but it's a pretty straightforward approach. So
that sounds very doable. Like we would just need enough people to devote some engineering time and, you know, maybe throw in some money to get some bigger runners than the standard ones. But yeah,
yeah, the it's it does take a long run. But I've just cloned the repo myself and done some of those things locally, and the builds are actually pretty straightforward to do. Changing options is a little more involved, but the things that are there run just run, and so it's not a huge issue. You just need somebody to own it and you know do it.
And to
I think
say
the
this
key
is the blast repository and the blast builds that the consortium has decided is the LTS version.
right, right. Now I think the hard part is not necessarily going to be that. The hard part is going to be like, what are the, like I said before, like, do we pin to a specific like LLVM major version and provide support for that? If so, how long, how many versions, what's the release cadence? To me, those are going to be the harder things to answer. Once we have that, then setting this up shouldn't be too difficult. But of course, somebody will have to own it. So anyway,
Yeah, I think that's where we got to with the LTS before it all went on pause for a second, was starting to break down the action items to prepare for that and all those open questions. And I think we probably need to scratch document again just to collect them all. We did the same with the kind of defining the direction of the LTS that took a while to put together. We should probably do it all over again with like the nitty-gritty details so we can have a more structured conversation on it. I think sometimes looking back this year, we probably oscillated on some of the points a little bit too long. So things we can do better. Luke, sorry, you've got a hand raised. I missed it.
Yeah. One of the things on Ron's wish list reminded me of a thing that I think is a good idea for next year that we should work on, which is finishing this build targets.md spec thing that I just linked to. So this was something we started during last year, and it's based on the Preview 2 kind of ABI. And the idea is if I'm a producer toolchain, I don't learn anything about components. I just want to have a bunch of core functions with some well-defined names that are mangled from the WID automatically and core types that are derived from the WID automatically, which is kind of what Ron was asking about. And so you can have kind of like a WASI P1, like just give me a list of core functions, I'll import those, and then some post-processing tool will wrap it up into a component. So, and this is sort of like defining the spec, which is currently just an implicit tooling convention, as in just a practical convention between WASM component LD and the compiler that produces the core WASM that is fed into WASM component LD. So this is saying if you feed me a core module that has this shape, I will wrap it up into a component. So that's what this spec is. So we made some progress on it for preview 2, but we didn't kind of finish it because other things came up. And then we started saying, well, preview 3 is close. Maybe we should just shift it to that. And in particular, now that we want to kill Cabby Realic because of actually the embedded concerns and 10 other concerns, but also especially those, embedded concerns that Chris mentioned earlier, we're going to remove the Realic entirely. So that would, of course, impact this build targets MD because there would just be no Realic function. It would just go away. So once we kill that Realic, that would be a really great time to update this PR to target preview 3. So you could have the async stuff if you want it, the sync stuff if you don't want it, and no Realic, and it would just be a bunch of core functions. And so this would be great for producer tool chains so they can target a component. But also if you're a runtime, you could say, I'm only going to support this. And so what that would mean is you can take one of those core modules and just run it directly on. And so that doesn't handle the full generality of the component model. For that, we would need what Stephen was talking about earlier, which is the JCO approach, which takes a full component that contains multiple modules with multiple memories and smashes them all together. That's the general approach if you want to handle any component. But if you only want to make runtime that runs just one module that targets this ABI, this would be the spec for you. So anyways, it could unlock a number of different use cases. So that is a thing that we started on, paused, and I think should resume next year.
Cool. I wasn't aware of that. That's pretty nice. Thanks, Luke.
You bet.
I think we need to make a wish list for next year. A to-do list to keep us focused. This would be good. Cool. What was your thoughts on the suggestion that Stephen and I had of like, hey, if we could have a universal extension mechanism, would it provide a faster way to get the component model and other runtimes?
Yeah, I guess the devil's in the details of what that extension mechanism is, but I mean, I like that objective. You got the Jaco approach. This is one way, kind of
Hmm.
pre-process it away, and then you have the add plugins to support it, and that's another way. Yeah, there's a whole spectrum of how a plugin model approaches, and I guess I don't know enough to say how whether it would work it out, but it sounds potentially promising. Um, the neat thing about the Jaco approach is the WASM you get as the output should not have especially more runtime overhead than just a random blob of core WASM, right? Because it's just AOT compiling a bunch of stuff, and um, the component model does not itself add a bunch of runtime data structures. There's like the one table of handles, and that's a pretty small thing usually. So that approach seems like it potentially would have the least runtime overhead. So that's why I kind of like the Jaco approach. And uh, and I think we could share it between just so many projects if we just did the work to factor out the common bits of Jaco that are not JS specific.
Hmm.
That's come up a number of times. It just seems like a generally great idea. But the plugin approach, sounds, if especially if there's multiple use cases that could fit into it, component model just being one, then that could be cool too.
That would be cool. I don't know enough about it, so I'll ask the question because I've got the expert on the call. On the Jayco stuff, I think I overheard somebody say that there's like little bits of, is it right that there's like little bits of what was in WASM time, or is little bits of Rust that have been compiled to WebAssembly that support that framework for doing
Hmm.
some of the component model elements? Is that how it's working?
Yeah, there's, the internal WASM time implementation is a layered approach. What it does
Uh-huh.
internally is it takes a component and smashes it to core WASM and then feeds that to the underlying core WASM engine. So it's just trying to factor out that stuff. It
Yeah.
hasn't been well designed. The interfaces, is kind of like, hacked and hatcheted out. But I think that's the project is can we have a proper standalone project imported by WASM time, but also importable by Jaco that has, maybe more carefully defined interfaces. And then the idea is you compile the rest to WASM and then you can run it anywhere you have a core WASM engine, which is the whole point of this project is, so you got a core WASM engine. What can you do? It's like, well, can run a
Yeah.
compiler using core WASM that takes in the components, spits out more core WASM. I can run that. So very inceptive. But it works.
Oh,
But
yeah.
and I
Okay.
think it's also pay for play too. Like if there's any sort of like type conversions around strings and whatnot, just the conversions you need, I believe, get compiled, not
That's right.
all of them. So if
Hmm.
you only use a subset of those things, then just that subset is what's carried in that payload, which is kind of
Hmm.
nice.
Right. Yeah, it's not a fully general runtime. It's I compiled your one component. Here's the WASM needed to run just
Right.
that one
Yeah.
component, which could be, yeah, if it's a small component, using just a few types, it's going to be a very lightweight thing. Yeah, to the point. Otherwise, it hopefully should never be a thing of can I run a component on this? It's like, yeah, if you can run any core WASM, you should be able to, also run a component.
Ooh, that's pretty cool. Again, because I don't know. Could you do that completely as a ahead of time process then?
Hmm.
So
Yeah, at
you
the
do
same
that
point in time,
offline?
you're compiling the machine code, which I know in a lot of embedded cases you don't even do on the device. You do in like a nice
No. Yeah.
centralized compile server. Right before you compile the machine code, you do this component to WASM step. So it's just part of the build pipeline.
Oh, I'm sorry, you just made me laugh. Compiling the code for the device on the device itself. Ah, that's so cute. Like,
Right, right, yeah. Oh yeah,
mostly you
AOT
can't
for the
do it
win.
at all, but generally speaking, I think a lot of CTOs would totally freak out if they thought that was possible. They would be like, "Wait, what? You can't? No, no, we don't want that."
I understand, yeah.
Yeah.
Even in our bigger servers, we don't want to do it for security reasons. We want to lock down our processes and turn off chip capabilities. It's that
Yep.
cup.
Yeah, yeah, yeah.
Yeah.
I think there was an interesting conversation on Zulip this week. I stumbled across it this week that started off about performance optimization and took a left turn at security of running LLVM in a production environment, and what would happen if you actually gave it some code that would blow LLVM, and it's used in a lot of runtimes. And then folks were like, "Oh, what about crane lift?" Oh, and like, so I thought we were talking about performance. So it took a hard left at security and kept going for a very long time. But yes, yeah. Um, Folks, we're about 15 minutes away from the end of the meeting. I think we've gone through a lot. There are other people on the call that haven't had the opportunity to speak. I see Michael on the line and Emily and Rob. Any wish lists for next year you guys would like to bring up?
I guess one question I have is what's the best way to stay involved? You mentioned the calendar, the Bytecode Alliance calendar before. Um, where do the meeting minutes and the record, the videos, video recordings get saved, things like that?
Good housekeeping questions. One of the things we don't have is, and this is just, I'm trying to think of a quote from Dennis Thatcher, Margaret Thatcher's husband, but he swore a lot, so I probably shouldn't mention it. This is this is not this is just purely because how we set up the eSIG. So when we set up the eSIG, I set up ICS files as an easy way to share date and time and location of meetings. But because they're ICS files, there's no way to email people and say, hey, this meeting's cancelled or we're going to move it. And that is a downside. And I think I would like to do something about that next year so we have more of a communication channel for the eSIG. So at the moment, the videos are uploaded to YouTube and on the Bytecode Alliance YouTube channel. And there is a playlist specifically for the eSIG. The meeting notes should appear in the Bytecode Alliance GitHub repo /meetings/eSIG, and you will find them all there, organized by year. And officially, the approach for adding an agenda item would be to submit a PR to that, and then that makes sure that we see it. And I do check the PRs, and I do check the repository in the morning before the calls, just so I know what's going on. Then the meeting notes should go up there. The videos go up to YouTube. The calendar exists on the Bytecode Alliance website. If you go there, there's a link on the top bar to calendar, and you'll find a pretty cool little widget that gives you the month view, and it will show you all of the meetings that are going on, not just the eSIG ones. So you'll see the other special interest groups, and you'll see the community group or subgroup for WASI also listed there. So that's kind of cool. Then the ICS files are up on our Bytecode Alliance GitHub repo. So they're there. Communication, when I started this off, we had a Google Groups that folks were sending me email addresses and I would add them to a Google Groups. So we have an email list. It's up to folks to ping to request to be added, but it's there. And then the rest of the communication goes to Zulip and to the there is a eSIG channel in Zulip, but it is a little bit disjointed, I will admit, and there is a lot of scope for improvement. But that's where we are.
That sounds great. Thanks for the pointers.
Actually, it sounds terrible. We need to do a better job, but I think it's a good point for next year as well. How do we clean this up a little bit, just from an organizational point of view? Thanks, Rob. Emily, Michael, any comments?
Unfortunately, not much on my side. We've been internally trying to get things bootstrapped to actually define like the requirements we need within Bosch. So obviously everything we can do to try to establish a clear roadmap in January makes it easier for me to like pitch that to management. Just to try to understand where the web it's the, this like the if we could have anything in the world, understanding exactly where WebAssembly and particularly the interfaces are going in 2026 would definitely make my job easier. But I also realize that's an extremely challenging ask, and it's an evolving standard. So, but if I could wish for anything, that would be it.
A good roadmap, I think, would be good. That's a good point. Better communication, a nice clean roadmap, and then on the roadmap we can place really cool stuff like the proposal Luke talked about, like the extension mechanisms that Stephen and I were mentioning. That'd be pretty cool. We should, and the LTS and the documentation for that. So I keep seeing extra to-do items for me, but it all looks good.
That's what I was saying, that was thinking of. It's like, I want to contribute to that roadmap too. But
Excellent.
hopefully it's not all on you.
I see delegation. I like it. Thanks for volunteering.
What have I done?
Yeah. Cool. Okay, folks. If we've anything else we'd like to talk about, or we can wrap up the call.
I just want to say thanks so much to you, especially, and Stephen, for doing all of the hard work of keeping us all organized over this last year. I'm not volunteering to help out more. I hope somebody does. But thank you very much. Really. Thank you.
Oh, no, you're very welcome. It's for the support for you folks like yourself who come along that make it all worthwhile. The technology's fun, but the people are a lot more fun. And with that happy note, if we're not speaking beforehand, happy holidays, happy New Year, Merry Christmas, wherever you celebrate. And if we're not speaking beforehand, I'll be updating all the calendar and the updates and the schedule of the holiday period. I will be doing that. So we might not get the chance to talk again. Happy New Year and see you guys in 2026. I can't believe it's the end of the year already. Oof, crazy.
It is crazy.
It gets faster every year. It's the freaky bit. Ladies and gentlemen, thank you. Well, I will.
Yeah.
Thanks a lot, everyone. Much appreciated.
Thanks, everyone. Happy holidays.
Happy holidays. Take care.
Yeah. Yeah. We'll see you guys soon. Cheers. Bye.
Bye-bye.